Hello, good evening, everyone. A warm welcome to all of you present over here. Hello, Mr. Tanmay Bakshi. I, Divya Chabaria, Chairperson of IEEE ADIT Student Branch, welcome you on the behalf of entire team and participants. It's my honor to introduce one of the most dynamic technocrat, Mr. Tanmay Bakshi, as the speaker of this webinar. He is the software developer and the developer advocate at IBM, Ontario, and an AI architect. He is also an eminent TEDx speaker. Furthermore, he contributes at Google as a developer expert. Now, I would like to request Mr. Tanmay Bakshi, sir, to proceed for the webinar.
Wonderful. Thank you very much, Divya. I really appreciate it. And thank you very much, everybody, for joining in today and taking out the time. My name is Tanmay Bakshi. And before we begin today, I'm just going to start off by saying something. I really do hope you're all keeping safe, and I really do hope that you're all staying indoors. Now, I know the coronavirus has thrown a wrench in a lot of things that we're doing as humans. It has made people stop going to work. It stopped us from doing the things we usually do. And I know that this is a huge disruption in people's lives. But remember that at the end of the day, the only way to put an end to this pandemic is to stay home and socially distance yourself from everybody else. And really, by doing this, we're going to enable the pandemic to end quicker. And think about it, this is a great time to do things that maybe you wouldn't have gotten the chance to do if you weren't at home. This is a great time to be learning virtually. It's a great time to spend time with your family. It's a great time to connect with your friends, again, virtually, online. Again, social distancing does not mean isolation. So you're still allowed to connect with friends just online. Just don't be near people and you're good to go. So we've got to administer this vaccine socially if we can't do it biologically to put an end to the pandemic. And so once again, hope you're all keeping safe, stay positive, and we'll be out of this in the next couple of weeks. And so now, speaking of learning virtually, how about we jump right into today's webinar? Now, to begin with, I want to say that I have always been fascinated by the world of technology and really the impact that it has on our personal and our professional lives. And so I'm holding this webinar today to really get you excited about the world of next generation technology, the world of deep learning, machine learning, artificial intelligence, whatever it is that you call it right now. We'll be talking about that terminology in a moment. And really, the reason I believe this is so important is because if you think about it, we've always been generating data. We've always been using technology, we've always been using different applications, and these apps generate data. But here's the problem. We've never been able to really leverage that data and understand it semantically in context with other data, at least in an automated fashion. We would have to do that manually, and that's simply not scalable. But with the power of next gen tech like machine learning and deep learning, that's exactly what we can do. We can start to make sense of these terabytes and terabytes of data we're generating every single day. And so before I get sort of deeper into these technologies and sort of get you started and get you excited about this tech, I want to start off by saying a huge thank you to the team at the IEEE ADIT Student Branch for organizing the webinar. Huge thank you for putting this together. And specifically, I also want to say a huge thank you to Sarthak Shah. Him and I have been working together for the past couple of weeks to actually make this happen. So thank you very much for putting in that effort. I really appreciate it, and I'm really glad to be here today. And so, to start off, before we get into the world of next generation technology, I thought it would be valuable to sort of take a look at my journey into the world of technology and how I got started. And in fact, I'd like to give you a bit of a tour of my journey into the world of tech. And like any good tour, we're going to have to start off at the very beginning. So, how about we travel back in time by around 11 years to when I was 5 years old? Now, back when I was five, as a curious kindergartner, as you can imagine, everything that I would do would essentially be play, right? Regardless of what I was doing, it was fun because I was just playing and interacting with and learning about the world, the environment around me, because everything was so new to me at 5. And of all the different things I would interact with, computers were my favorite toy. And the reason for that was because they were flexible, they were dynamic. I could interact with them in infinitely more ways than I could interact any other one of my toys. They were so moldable. I could make them do whatever it is that I wanted them to do. They weren't rigid. They weren't solid. And when I noticed that, I started to get more and more fascinated by the world of computing. And my dad saw that curiosity that I had and introduced me to the world of programming. But my curiosity didn't just die there. Every one of my questions answered, I just had a couple more. And so I started to use more learning resources, and when I was 9, I had my very first iOS application called T-Tables accepted into the Apple App Store. Now, from there, I started to realize, well, sure, I can build software, but then why not also build content that enables people to write their own software? And so I started my YouTube channel called Tanmay Teaches, where I would upload tutorials ranging in topic all the way from iOS app development and programming to math and science. And the thing is, from there, I started to realize, sure, I'm creating content that helps people, but even on that content, I'm getting hundreds of queries from people across the globe, and these queries are asking all sorts of questions about the world of technology and programming, and they're on all sorts of different media. And so I realized that there is a lack of resources for the beginners that want to get into the world of technology. And so this led me to do one more thing. I went ahead and initiated my goal to reach out to and help at least 100,000 aspiring coders to really help them innovate along their journey of learning to code. In fact, I'm glad to say that so far I'm around 16,000 people there, and really I'm working towards this goal through all sorts of media. I mean, I mentioned my YouTube channel, but then there's the talks, the workshops, the keynotes that I have at schools, universities, conferences across the globe. Really making it so that if someone has an idea, they actually have the technical expertise to implement that idea with the power of technology. In fact, I'm also very glad to say that just last year, to scale up this initiative, I had 3 of my tech books published as well. These are Hello Swift, Cognitive Computing with IBM Watson, and Tanmay Teaches Julia. So hold on a second. You're looking at the books and you're thinking, we've already gotten into the world of next generation technology. So how did it get here? And to sort of talk about how I got into this next gen tech, how about we take another step back for just a moment? Now, if you remember, I initially got into the world of technology at 5 because I felt technology was more flexible than anything else I could interact with. But I was slowly starting to realize that technology wasn't nearly as flexible as I thought it was. As a matter of fact, technology is pretty rigid. Technology, back when I was 11 years old, I started to realize was very hard coded, right? It only does exactly what humans tell it to do, no more, no less. That's it. That's it. It works off human rules and conditions. And that wasn't really interesting to me because technology couldn't adapt. It couldn't understand the data that users generated while using applications or while using technology. But I'm also at the same time really lucky because what happened was I eventually stumbled upon something that completely changed my conception of technology. And what I had stumbled upon was a documentary on IBM Watson and how it not only played but won the Jeopardy game show against the 2 best human competitors on the game show. Now, just for a second, think about what that meant. I mean, I went from thinking that technology is rigid and inflexible to now seeing Watson, a computer system, playing one of the most complex game shows we know of. One of the most complex game shows we as humans have put together. It's understanding puzzles, riddles, wordplay, puns, and it's doing this by understanding Jeopardy clues and correlating them to like 40 terabytes of unstructured information on Watson's drives and coming up with responses in under 3 seconds. That is absolutely incredible. Nowadays, we kind of take this technology for granted, but you've got to realize this is unfathomably complex software. In fact, this is my favorite application of machine learning technology ever. And so, really, when I stumbled upon Watson, I was like, I'm intrigued by whatever goes behind Watson. And I eventually figured out that it's this machine learning technology. And ever since then, I have been hooked to implementing this tech in a wide variety of different fields, essentially all of the different applications that I develop. And so you're probably wondering, well, why is machine learning so exciting to me even now, all these years later? And really, the reason I love machine learning so, so much is because of its wide scope of impact. As a matter of fact, that brings me into what it is that I want to talk about today. I want to split this webinar up into three distinct parts. First, we're going to be talking about the impact that machine learning technology has on our lives. Then we're going to talk about the architecture of machine learning in larger systems and dispelling sort of the myths that people have about how machine learning is implemented. And then finally, we're going to be talking about the technology and the implementation of machine learning algorithms. So I want to start off, of course, by talking about the impact. Now, in order to understand the impact of machine learning, I believe we got to really distill what it is that machine learning enables us to achieve. And if you were to ask me to do that in the simplest way possible, this is how I would do it. It's scalable and automated insights extraction from both unstructured and structured data. Now, that's a lot to unpack, so let's go ahead and break that down a bit more. So, what exactly does this mean? Well, let's start off with insights extraction. What that means is that for the first time ever, we can mathematically understand the meaning of data in context, not just as an isolated individual unit, but what that data means in relation to all the other data that it is you have. And we can do that in an automated way, meaning it's scalable for the first time ever with machine learning technology. But what's so special about machine learning today, modern machine learning, modern ML is what I'm going to call it, is that it can understand any kind of data, unstructured or structured. Now, if you don't exactly sort of unpack what unstructured and structured means, that doesn't really seem that impressive, but it's actually an incredible capability. I mean, unstructured data is absolutely everywhere. You don't realize just how prevalent unstructured data is. I mean, 80% of all the business relevant data that we generate as humans is entirely unstructured. And to understand why understanding unstructured data is so difficult and yet so important, I believe it's important to understand what unstructured data really is. Now, I believe that unstructured data is actually pretty simple from a conceptual standpoint. It's the kind of data that we as humans use and generate to interact with and understand the world around us, our universe, our environment. That's the data that we have evolved to use for tens of millions of years now. And I believe there are a few key examples of this unstructured data, these unique human abilities. And I want to start off with natural language. Now, natural language is incredibly complex. It is unfathomably complex. I mean, we as humans have this unique capability of being able to not only imagine and conceptualize and visualize scenarios that we have never been in, abstract concepts that we've never concretely experienced. Not only do we have that imagination, but we also have the capability to encode that imagination into words and tokens, and then share that with other humans so they can also create that sort of conceptual map in their mind. That is incredible. We have the most complex communication abilities of any animal ever. But here's the thing. Natural language is complex, and we use it all the time. This webinar is filled with natural language information. But the problem is that without machine learning technology, computers and tech cannot understand natural language. So if you've got a data set of natural language, it's basically just sitting there waiting for a human to see it, and computers can't do much with it. But when you bring in machine learning into the picture, you start to get some incredible applications. Like, for example, my favorite, IBM Watson playing Jeopardy! Not only is it understanding natural language, it's understanding some of the most complex natural language we have ever put together, purposefully filled with all sorts of puzzles. And it's doing so at superhuman levels. That is absolutely incredible, the fact that Watson can understand unstructured data like natural language. But of course, natural language isn't where we draw the line. There's all sorts of unstructured data. For example, visual data. Now, visual data, the images that we take or the videos that we record, This is a bit more relatable in a sense, or easier to understand. Because, I mean, even take a look at the eye that you see on screen right now. Now, this eye on my computer doesn't have anything special to it. It's just a series of bytes, but what happens is that series of bytes is understood by the programming that we as humans have put onto this computer, and it's displayed on my screen. And when my eyes actually perceive those photons coming from my screen, then my mind is able to assign meaning to that image. It's able to say, hey, there's an eye in that image. Otherwise, it's just a series of photons in the physical world and a series of bytes on your computer. It really has no meaning to it. I mean, there's photons all across the universe. There's no meaning to them. But when we perceive those photons, we assign meaning to those photons, and that is absolutely incredible. And here's the thing. Computers can't do that. Computers are just storing the information and displaying it to you whenever you want it to be displayed. That's all they're really doing. But with the power of machine learning technology, we can start to understand that visual data with the help of our tech. Great example would be Tesla Autopilot. I mean, think about this. Back in 2014, when Tesla launched Autopilot, they made the commutes of drivers safer, faster, and easier, all with the help of machine learning. What they did is they enabled the cameras and sensors in their Tesla cars to actually be used to understand the environment around the car automatically. In order to understand, hey, there's a lane marker here, so I should stay within my lane. Hey, someone's following really close behind me. Or maybe an accident's gonna happen up ahead. Maybe I should stop right now. Early braking. It does all this sort of stuff. It understands that pedestrians shouldn't be hit because it's able to understand the world around it using techniques like convolutional neural networks and all sorts of different machine learning technology. And of course, how could I end this topic without talking about auditory data? I mean, when I'm talking right now, what I'm doing is I am taking molecules of air and I am vibrating them in a certain way. And air molecules are vibrating across the universe. That doesn't mean there's any meaning to them. But when your ears pick that up and when they convert those vibrations into electrical signals and pass those electrical signals to your brain, you somehow create meaning for just a bunch of vibrations. And that is incredible. The word vibration is just a bunch of vibrations of air. And you pick that up and you recognize the pattern of those vibrations. And that is an absolutely unique skill to animals in general. And of course, with the power of machine learning technology, our computers have that skill now too. I mean, think about it. If you pick up your phone, in a lot of cases, you can just take your phone and talk to it. You don't even need to touch it in a lot of circumstances to get a lot of things done. You can use your phone entirely hands-free. Apple's Siri, Google's Google Assistant, Alexa from Amazon, all these different personal assistants are understanding auditory data with the help of techniques like recurrent neural networks and other machine learning algorithms. And so, unstructured data is complex, it's fundamentally human, it's important. A lot of the data that we generate is unstructured. And with the power of machine learning, we can start to understand it. Now, from here, you're probably wondering, well, why do we need machine learning in the first place? Well, it's because computers, from the very beginning, have had a very narrow scope. By a narrow scope, I mean they have been built exclusively to crunch numbers, exclusively to run mathematical operations and transformations. That's it. That's all computers are good for. And the problem is that mathematics are quite limited because we as humans, we don't know how to write the individual fundamental mathematical transformations associated what you said in a certain audio clip, or understanding if an image contains a cat or a dog. We don't know how to do that because that is so deeply ingrained into our subconscious minds. That is not an ability that we have, and it's not a thing we can do. But here's the thing. With machine learning technology, we don't need to do that. We can literally just use the mathematics that our computers are already good at and say, all right, here are some examples of data. Now learn a mapping, learn the causal link between these two different data sets. And we can start to use this magic math skill of computers in order to solve the very problem that we face. And so that's the impact of machine learning technology. It enables computers to do things they could never do before. But then, of course, there's also the architecture of machine learning in larger systems, not just the individual machine learning algorithms, but then from there, how they are implemented into larger pipelines and larger machines and systems. And I want to give you a bit of an analogy first. So think of machine learning algorithms as, say, the human brain. Now, the human brain is incredibly complex, takes a lot of resources, and it is literally the reason you're alive. You are your brain. And the thing is, the brain, while it's incredibly useful and fundamental to our existence, it is pretty much useless if it doesn't have the infrastructure to support it. You require an entire body just to create the resources necessary for your brain to continue to function. And of course, for your brain to have input output mechanisms. So, what I'm saying here is that machine learning, the brain, is important. And without it, the body, the infrastructure, has nothing to do. But the thing is, without that infrastructure, the brain can't really do anything either. Sure, you've got a cool little algorithm or a cool little brain in a jar, but you can't do anything with it. And so let's apply the same analogy to machine learning now. Let's start off with a small example, the Apple Watch. Now, if you've got an Apple Watch Series 4 or higher, then what it's going to do is if you take a hard fall, it'll detect that fall and it'll call emergency services if you don't respond on the watch. And it'll share your location with them. But that entire pipeline isn't just a single deep learning system that they put together. It's not an intelligent watch that realized you fell and that it needs to give you a notification. Rather, the machine learning part is actually pretty small. It's basically just taking the accelerometer and gyroscope data and simply outputting, did the person fall or not? And then it's up to the actual engineers behind the system to gather the data in a battery life sensitive way and then pre-process it and then feed it into the system and then take the output of the machine learning system and then go ahead and show a notification if the user fell and then go ahead and contact emergency services and share the location. All of that is very critical. It's vital infrastructure for that machine learning part to be useful or to be a meaningful user experience. But it doesn't just end there. We can scale up this analogy to hundreds of more complex examples. Like, for example, AlphaGo. Now, AlphaGo is a super popular example of deep learning technology in action, playing the Go board game, where the state space is larger than the number of atoms in the observable universe. That's a lot of states. That's exponentially more than chess. I mean, we can brute force chess, but we couldn't brute force AlphaGo if we used every computer on the planet for a million years. We simply cannot do it. It's complex. And so what AlphaGo does is it uses this sort of symbiotic relationship between deep learning systems and traditional search algorithms like Monte Carlo tree search, answering simpler questions like, from a board state, what are my chances of winning? Or what are the most likely moves of my opponent in order to guide the search in the correct direction. So AlphaGo isn't just a single deep learning system where some random researcher went, hey, here are a bunch of board states and the moves that some experts made, learn. That's not how it works. Rather, it's this sort of larger system where deep learning is integrated into certain components to solve subproblems that were so far infeasible to look at. And so that's really what makes AlphaGo so powerful. And finally, one of my favorite examples would be IBM Project Debater. Now, Project Debater is a system developed by IBM Research to engage in debate against professional human debate champions. Now, that is incredibly complex. Think about that. Let's just say I were to say we should ban alcohol. That's a debate motion. We should ban alcohol. Now, you would think that the debate would be on the pros and cons of alcohol, but that's not it. The debate is actually on all sorts of stuff. Because think about it, when you ban something, you generically open up the possibility of a black market. And maybe for alcohol, that's better or worse than it is for a different kind of drug. So you've somehow got to expand your search space and understand and model human dilemmas and their relationship to each other. And Project Debater, again, it wasn't just a researcher sitting in some research lab somewhere saying, all right, here's a deep learning system, here's some motions, here's some narratives, go ahead and learn. That's not how it works. It's not a single black box. Rather, it's a bunch of little problems that researchers found and they solved with deep learning systems. And they put together this entire infrastructure of debating through computers, computational argumentation. It's not just a single system, it's individual components working together, manually architected with human expertise. And so that's the architecture of machine learning systems. Finally, we can get into the world of technology that goes behind machine learning. Now, I've already talked about what machine learning enables us to achieve. But when you boil away all the excess and the sort of business aspect of it and the societal impact, when you boil away all of that and you look at the core fundamental mathematics and technology, you start to realize that machine learning is incredibly simple from a conceptual perspective. And the reason for that is because machine learning is just this. You've got two data sets, X and Y, and you know that there is a causal link between X and Y. So if I were to give you X, there exists some mathematical function that can take X and give you Y, even if Y doesn't exist yet. Even if Y will be generated in the future, you can predict Y based off of X. So you know that a mapping exists. But the entire business problem here is that you cannot find the mapping because it is incredibly complex. We don't know what the mapping is of Jeopardy clue to response. We don't know what the mapping is of debate motion to debate narrative, or from go board state number one to next move. We don't know that mapping. And with machine learning technology, we can find it because we don't need to hard code those mappings. The machine learning technology is finding it for us with the power of some fancy math, calculus. And I know when I say that, it might scare you a little bit, but don't worry, it's not as complex as you may imagine. It's actually quite a bit simpler than you may initially think. Now, specifically, I'm talking about deep learning technology. And deep learning technology is kind of like a subset of machine learning technology. Now, if there are tons and tons of different machine learning algorithms, uncountable numbers of them, then deep learning would be sort of like an umbrella term under the umbrella term of machine learning, specifying these things called neural networks that are essentially based off of a few key building blocks, and they're inspired by the human brain. Really quickly, I don't like the analogy of inspired by the human brain very much, even though I use it, because it gives you the wrong picture. The reason I say that is because if you take a look at an individual node, a neuron within the human brain, and if you take a look at its counterpart, a perceptron in a deep learning system, you'd realize that they're entirely different. They do not resemble each other in any way, shape, or form. But the thing is, the way neurons are structured and the way perceptrons are structured, that is similar. So the individual nodes are completely different, but the way they structure together is similar, and therefore their emergent properties are also similar. And so it's inspired by the brain, but in a different way than you may think initially. So that's why this analogy is something that you should be taking with a bit of a grain of salt. But regardless, I think now, instead of me just talking about deep learning and machine learning, let's take a look at some actual demos of neural network technology in action. We're going to be taking a look at three demos: the TensorFlow Playground, the MNIST Classifier Explorer, and then something called Write with Transformer. And so now, without any further ado, let's hop right into our demos. Now, one more thing I want to share, there is another demo that we could do. If you would like to see it, do let me know in the YouTube live chat. And one more thing, if you've had any questions so far, please do leave them in the YouTube live chat. We will be having a live Q&A session after this, so any questions, I would love to answer them. Just keep putting them in there. We're going to take a look at the questions and I'll answer them in just a moment. The extra demo I was telling you about is about the actual working of an individual perceptron, so you can see the TensorFlow code of optimizing a single perceptron to understand that better. So if you'd like to see that, do let me know, and we can do that as well. But first of all, we're going to jump into the TensorFlow Playground. Now this over here is called the TensorFlow Playground. I will link to this in the YouTube live chat after the live stream in case you'd like to play with this, or else you can just go to playground.tensorflow.org right now. You can already see that on my screen. And the TensorFlow Playground enables you to play around with neural network type technology. So really quickly, I know there's a lot of knobs and dials and buttons and switches on here, but I want you to ignore them all except for the ones that I interact with and that I tell you about. So first of all, let's take a look at the right. You've got a graph with a bunch of dots on it. Now, these dots are of two different colors, orange and blue. You can tell as a human that there are two different clusters of orange and blue dots. Now, here's the thing. Each dot has an XY property. Now, as humans, we can tell that if it's in the negatives, then it's orange. If it's in the positives, X and Y, then it's blue. But the thing is, how exactly would a neural network take information about a dot, like for example, how far to the left or how far to the right it is, and then classify if it's orange or if it's blue? Well, that's exactly the problem that we're going to be solving now. So let's take a look at how we can do that. Now, what we've got over here in the middle is called a perceptron. It's really, really simple. It's essentially just multiplication. Now, on the left, we have these things called features, which describe properties of a certain dot that are fed into the perceptron so the perceptron can make a decision as to whether or not, or as to whether a certain dot is orange or blue. Now, this feature over here activates negative, so towards -1 if the dot is to the left of the screen, and it's more positive if it's more towards the right of the screen. Up, down does not matter or change the value, only left, right, okay? Only horizontal movement will change the value of that feature. So if I go ahead and click on this, what's gonna happen is the value of this perceptron will be the value of this feature for a certain dot multiplied by this weight value. And then the output on this graph will be equal to the perceptron's value multiplied by another weight. So if I go ahead and click on the play button, watch this. Boom, just like that. What happened now, what happened just there was the machine learning system, this neural network, this perceptron, just learned that hey, if a dot is towards the left of the screen, it's orange. If it's towards the right, then it's blue. Now this isn't particularly the best mapping that it could learn. And let me tell you why. Let's just say we feed in a similar feature, but it activates positive towards the top and negative towards the bottom. So left, right doesn't matter, only top, bottom. If I go ahead and click play, as you can see, it's essentially drawing a line right down the center of the graph, but there's still a little bit of misclassification. So a diagonal line seems to be the best choice here. Problem is that the network doesn't have the correct features to use in order to make that diagonal line. You have to feed in both left, right, and up, down data to create that diagonal line. So what we're going to do is feed in both features, and the value of the perceptron is now the sum of the weighted inputs. So if we run this now, watch, we get a diagonal line, which just so happens to be the best fit. Now this data is super easy to use because it's linearly separable. That means a straight line can separate the two clusters. But not all data is like that. For example, if you take a look at this data set, you can't just draw a single straight line and separate the orange from the blue. But if you add more perceptrons and more layers, and you have more and more connections and more features, then watch this. Just like that, you're able to learn increasingly more complex representations. But it's not even just that, there are all sorts of hyperparameters that you can tune to, like the learning rate. Do you want the network to learn faster or slower? There are advantages and disadvantages to both. So for example, learning slower sometimes can mean a bit less jittery learning and more fine-tuned steps. And over here in the middle, you can actually visualize the connections between different features and different perceptrons that are contributing towards that mapping. And as you can see, it happens that the neural network has learned this sort of curve around the corners where it wants to classify as orange. And so there are all sorts of ways that you can structure these networks. And there are two things that I want you to realize. Over here, we have two neurons or two features, and then three perceptrons, and then three perceptrons, and then one. So that's only a couple of connections. But these can get into the billions of connections. And I mean, our data in this case is just two dimensions, x and y. But imagine dealing with three dimensions, or four, or 10, or 10,000 dimensions of data. I mean, two dimensions, it might seem simple to just take a pencil and draw a line around two clusters, but then when you're dealing with millions of data points in thousands of dimensions, the human mind becomes incapable of visualizing that. We only live in a universe with three spatial dimensions, so you can't visualize more than that. And that's why machine learning technology is necessary. We cannot scale human intelligence to thousands of dimensions and millions and billions of data points. We need the power of machine learning to do that for us. So this is a simple multi-layer perceptron neural network. Now, how about we take a look at a more complex network, something called a convolutional neural network. Now, convolutional neural networks are pretty amazing. You can use them to understand visual data. So for example, if I go ahead and draw, say, the number 8 over here in this box, as you can tell, this neural network is like, hey, you drew an 8. See how the box under 8 is really lit up right now? It's like, I'm very sure that you drew an 8. And why is it saying that? Well, it used this network over here that I'm visualizing in order to actually take a look at what that 8 is. Now, what happens is we start off with some input. And what happens is these individual convolutional layers are representing the images in the image in their own ways. So in this case, we're creating 6 different representations of that image, each representation highlighting certain features of the image. For example, this convolutional layer here seems to have learned to activate towards the top side of curves. So for example, if I were to draw a 3, you will notice that this layer, yeah, it activates towards the top of the actual curves themselves. And so you can take a look, this one activates towards the edges, like the sides of curves, and there are different patterns that they learn. And then from there, you can do things like make the image smaller and then create more representations of the representations. This is a multi-layer aspect, and then make those smaller and then connect a perceptron to every pixel in every representation of the representations of the images. See, we're getting to multiple layers now, enabling us to understand more and more complex shapes in this dimensional space. And by therefore connecting another fully connected layer, another layer of perceptrons like we just saw in the neural network playground, we're able to then classify as a 3. So what's happening is we are getting increasingly longer and less deep representations of the data. And by doing so, we are able to classify it into a 3. And so that is a 3D visualization of a convolutional neural network. But finally, what would this demo be without also demoing some recurrent neural network technology? Now, this is a demo called Write with Transformer. Now, Write with Transformer is actually pretty interesting because it uses a technique called recurrent neural networks. And recurrent neural networks understand data over time. Now, I wrote this sentence myself, and you're probably wondering, well, what are recurrent neural networks? Well, think about a sentence like this one. The word networks means something different if the word neural, or if the word computer, or if the word biological came before it. And so in a way, you could say that this sentence is a time series of data. First there was the word recurrent, then the word neural, then the word networks, and then understand, and so on and so forth. Because the order of those words does matter. And using recurrent neural networks, you can understand this kind of time series data. And the transformer is a very large recurrent neural network that has been trained to generate text based off of the context before it. So watch this. If I click tab, it's gonna autofill what it thinks I want to write. So, which this is incredible. So I wrote recurrent neural networks understand data over time, and the neural network itself predicted that I want to say they are the underlying technology behind our predictive analytics, and that is correct. So I'm gonna go ahead and click enter, and we can continue to just keep clicking tab and keep filling this out. And just like that, we're gonna have a whole sentence that the neural network will write. Now, these individual sentences, of course, may not be completely technically accurate or may not be factual, but what matters is that the neural network has learned a representation of how to fill out text, how to understand the structure of a document. I mean, this wasn't even trained on question answering, and I can still do things like question, who is the Prime Minister of Canada? And ask it for an answer. And just because it needs to fill out the document, it recommends things like Stephen Harper or so on and so forth. I can keep clicking tab and getting new recommendations. There we go. It gives us Justin Trudeau now. And it even fills out the next question because it thinks that's the format of the document. And it's going to keep saying, and now it's asking, who is the Prime Minister of the United States of America? Doesn't necessarily make complete sense, but you can tell that the neural network has learned these patterns of what comes after what. So this is pretty incredible stuff that this neural network is doing. And it just goes to show that when you have billions of connections and terabytes of data that you're feeding into your networks, you can do some really amazing things. And so finally, before I go today, one more thing that I want to show you. I know I talked about IBM Project Debater, and I have access to a version of IBM Project Debater as well. And what I did is I fed it the debate motion, we should ban net neutrality. And of course, that's a bad thing. So I told it, Debater, give me a debate narrative on why we should not ban net neutrality. And it generated the following speech. And I want you to read it. But the thing is, I don't just want you to read it, actually. I want you to listen to it. I want it to be narrated to you. But I don't want to say it, and at the same time, I don't really want to build an entire machine learning system to synthesize audio just to have you listen to this text. So, IBM Watson comes to make our lives so much easier. Now, IBM Watson in this case is essentially going to act as this set of services that enables us to use machine learning, like for example, transformers and convolutional networks and all these things, without having to understand how machine learning works. In this case, we're using something called a text-to-speech service. So watch this. Without me having to write a single line of code, I can use Watson to synthesize audio for this debate narrative generated by Debater on why we should not ban net neutrality. And without any further ado, I hope you enjoy Debater's speech. We're going to let that generate, and you should be able.
Greetings. The following speech is based on 365 arguments submitted by the crowd, contesting the notion that we should ban net neutrality. There are 4 issues the crowd has raised, opposing the perception that we should ban net neutrality: technology, privacy, social justice, and level playing field. Technology first. Net neutrality ensures that the internet remains a free and open technology, fostering democratic communication. It puts everyone on equal terms, which helps drive innovation. An open internet that has seen tremendous growth and innovation provides an engine for economic growth and serves as a platform for expressing ideas, thought, and creativity. The next issue is privacy. Penwasp also believes that net neutrality and privacy is crucial in creating a free and open internet. Lahad opposes net neutrality and believes that revoking it has zero effect on privacy or data collection. Fundamental freedoms, openness, unity, and net neutrality remain as the building blocks of the internet. Net neutrality is crucial for the development of decentralized networks. It will help build jobs in the 21st century. Turning to social justice. Net neutrality is also important for communities of color because it allows for them to tell their own stories and organize for racial and social justice. It is something that is essential for small businesses, for consumers, and it is essential to keep the freedom associated with the internet alive. The final point is level playing field. Net neutrality is essential to keeping the internet a level playing field. The repeal of net neutrality would turn internet service providers into gatekeepers, allowing them to put profits over consumers. These were the arguments from the crowd, opposing the idea that we should ban net neutrality. Thank you for listening.
That is pretty incredible to think that a computer system put together that debate narrative just by looking at the internet and Wikipedia. And so now, without any further ado, that concludes our demos. I would love to get into what we have planned next, but just before we go, there's something I want to leave you with. And that is that when we put out the invitation for this webinar, I did not specify a certain group of people or a certain industry or a certain area that people should be from in order to understand this. In order to understand this webinar or to join this webinar. And the reason I said that is because it is critical, I believe, for everybody to understand technology in general, but also especially machine learning, deep learning, AI, whatever you call this next-gen tech. And the reason I say that is because if you think about it, this next generation technology is impacting all sorts of fields, from healthcare to agriculture, from finance to the world of to really so many industries, education. All these different industries are being impacted by the world of machine learning technology. And the thing is, in order to apply this technology in the best way possible, we need to understand it. We have to have a good comprehension of what really goes behind it. And so now, without any further ado, I would love to get into whatever it is that we have planned next. I believe we've got this little fireside discussion and then any question answering session to answer any questions you may have. So who am I going to hand this back to?
Yes, Tanmay, over to you, Harsh Bansal.
Wonderful. Oh, you're muted.
IEEE chairperson, and it was very honorable to get in touch with you. And we would be conducting a fireside chat with you, with me and my colleague Divya. Divya, please introduce yourself.
I'm Divya Chhabaria, the chairperson of IEEE ADIT. It was nice listening to your session, Mr. Tanmay Bakshi. So let's start with fireside chat. Uh, Realizing the present situation, how's quarantine coping up with you? Like, do you have any lockdowns there?
Well, yes, of course. I honestly, I recommend that everybody across the world, regardless of government lockdown, stays indoors. And of course, here in Canada, we've got the government really strongly recommending and advising that everybody stay at home. And for very good reason. I totally understand the reasoning behind it. In fact, I very much so support it. If we don't have a biological vaccine to give us this herd immunity protection, we've got to do it ourselves by actually staying indoors and not getting infected and not infecting others, so we don't infect the people that are out there doing work that is critical to our society functioning. And so, I mean, I'm keeping up well. Things are obviously not as efficient as they would be, not in a situation like this. People can't go to work. It's not as nice, but at the end of the day, I believe that it's important, and therefore I really have no complaints about it.
Well, Tanmay, as you said right now, during the global pandemic, you must have heard about Folding at Home platform, which uses the computing power of various donor machines. And
Yes.
people can even contribute their computers to help the process. Can you please explain us what they do with all of these computing powers?
Absolutely. Now, high performance compute has been an area of interest of mine for a very long time. And high performance compute enables you to do really, really amazing things. Like, for example, taking a look at, actually, let's start off with an even simpler example. And this will really give you an idea of how complex this kind of stuff is. So let's just say you were to take a super simple molecule with just a couple of atoms on it. Now, let's just say you wanted to simulate a nanosecond of this molecular activity in a total vacuum on the world's largest supercomputer today, IBM Summit. That would take just under a week of compute power. So, computing the real world and like molecular and atomic interactions on computers is very, very inefficient just because of how the universe is. It scales exponentially. There are more mathematical operations involved with that small nanosecond of molecular activity than you can possibly imagine. So imagine proteins. Proteins have all sorts of molecules working together to fold in certain ways, and therefore act in certain ways, and act together in certain ways too. And trying to simulate the activity of proteins and the way they fold is very, very difficult for computers to do. And it takes immense amounts of compute power to do even simple simulations. And so the idea behind folding at home is that instead of just having one large supercomputer, you've got donor machines across the globe, all doing their own folding of proteins, and they're all contributing towards the computation that the larger cluster is doing of protein folding. And by understanding the behavior of, for example, spike proteins on the coronavirus, or the way they interact with other proteins in your body, these sorts of things, we can be closer towards developing vaccines or drugs or understanding how the virus works for future research and so much more. So by donating compute power, which I believe everybody should be doing, you are really working towards helping us solve this pandemic.
Okay, so like talking about your backside story, when did you started? Like, what was your first computer? How did you develop? When IBM approached you, can you please elaborate on this?
Sure. So if you were to ask, specifically you asked, so what was my first computer and sort of what was my first sort of few things that I did with the world of technology? I mean, I did say that initially I got into the world of tech when I was around 5, as a curious little kindergartner, just playing with technology, playing with a computer. As you can imagine, it was just a toy for me back then, right? I didn't realize that what I was doing was something that people do for work. It was just, hey, I'm fascinated by technology, I might as well play with the computer. That's really all it was for me. And so I would basically code in quite literally random ideas. Like for example, I would create little SQL tables of holding like the stock of say an ice cream store, or the different things that people have, or creating little calculators in C or Visual Basic. And then I also started creating YouTube tutorials on Visual Basic of how you can create these calculators and these copying applications and all these sorts of different things. And so and so that was sort of the first few things that I did with technology, essentially really just playing around with tech back when I was 5. But then from there, when I started to sort of scale things up, I mean, as you mentioned, IBM, when I started working with Watson, the way I got in touch with IBM was actually pretty interesting. Because what happened was I was working with a service of IBM Watson called Document Conversion in order to write or in order to record a YouTube tutorial. And I had found a bug in the service on Bluemix, which was IBM's cloud platform. And so I posted that bug to Stack Overflow, and a couple of IBMers actually saw that Stack Overflow post after I tweeted about it. And my Twitter and my Stack Overflow led them to my YouTube channel, which led them to all the different work that I do, and they saw my different Watson tutorials and my different iOS tutorials and so much stuff. And that sort of led me to start working with sort of collaborating with at the time IBM and a bunch of other companies on lots of different projects. So really, ever since then, I've been working with them on that. As a matter of fact, some of the first people to reach out to me from IBM, now my mentors, of course, were Timothy Duncan and James Archieri. Really sort of said that, you know, if you ever have anything that you need or any support or any questions, you can reach out to us. And since then, I've been working with them. They're my mentors, and that's how I got in touch with IBM originally, and that's sort of how I started working with Next Gen Tech.
Nice, good story, Mr. Tanmay. I would like to ask you, for every person, there's one person they look up to. So, can you name a person who has had a tremendous impact on you as a leader? Maybe someone who has been a mentor to you, and why and how did this person impact your life so much?
Sure. So I'm gonna break that up in two parts. You said the mentor and the impact part, and I'll get to that in a second. You said first of all though, sort of like an inspiration or someone that I look up to. So I mean, from that perspective, I would say that there's sort of two people that I kind of look up to in terms of that, and they would be Steve Jobs and Elon Musk. And the reason I say that is because if you think about it, first of all, Steve Jobs, sort of the dedication and the passion that he had towards the work that he does, and sort of his genuine dedication towards never giving up and always persevering. That's absolutely incredible, and I love that. And then Elon Musk, from the perspective of he's got this sort of drive of implementing AI and machine learning and all these next gen technologies, even more than this, and not just talking about it, actually doing it. Now, there are some views of his that I don't necessarily completely agree with around like artificial intelligence or whatever else. But overall, his passion of, you know what, we can make self-driving cars instead of just talking about it. Let's actually do it. Let's put it on Tesla cars. That's incredible. But then to go to your second point about mentors and people who've had an impact on my life, there are numerous people that have had a very large impact on the work that I do and sort of and really everything that and sort of supporting everything that I do. All of my mentors, really. I mean, I've already mentioned Timothy Duncan, James Archieri. If it weren't for them reaching out for that first time and actually giving me that support, I wouldn't be doing what I'm doing. There's also my mentors like Rob High, the CTO of Edge Computing at IBM, the former CTO of Watson. I've worked with him quite a bit. He's given me a lot of guidance, a lot of advice along my journey. And it's really so many people that are providing guidance in their own ways, in their own sort of areas of expertise. So a huge thank you to all of them for sort of providing that. And I would say that it's not really one person; it's a group of people as a collective in their own individual areas or fields.
It's great. We have the next question. What is that one incident when you felt deprived of the solution?
Felt deprived of the solution. Okay. There have been many situations like that. When you program, there are always going to be situations like this. That's just how programming is. I will say though, one of the most frustrating bugs I've ever dealt with, when it comes to programming at least, was this one time I was working on a project at IBM, and I was working on a code base with like hundreds, not hundreds, tens of millions of lines of code, so like 25, 30 million lines of code. It was a really, really large project. And this is a project that like multiple enterprises use, across the globe. And I'm building compiler tooling, and the point of the compiler tooling is to sort of interrupt the compile process of the project and sort of inject code into every single function, trace function calls in the program as it runs. And as I was doing this, I was always getting Stack Overflow errors whenever I injected my functions, but not when I didn't. And there was no recursion in any of my functions or any of the code base's functions, and I couldn't wrap my head around why it was giving me a Stack Overflow error. And it turned out that the code base that I was using was so complex, it was overwriting some memory allocation functions. And my shared library that it was calling out to was using memory allocation functions. So those memory allocation functions would end up calling the project because it overloaded those functions. But because those functions were in the project, those functions would try and call my library again. But then my library, when it would be called again, would try and allocate memory, which would go back into the project and back and forth. And analyzing those stack traces, I couldn't figure out why that was occurring because I didn't know that the function was overloaded. So there are always scenarios like this where the solution is basically right in front of you, but just because you're missing like a few aspects, it took me like 3 days to actually figure out that, hey, the function's being overloaded. That's why we're getting this infinite loop. And then there were so many issues after that and before that. But again, these issues are just a natural step in programming. So there are always going to be things like this. And it's really just up to figuring out what it is that you've missed or that you don't immediately see. And every time you solve one of these problems, you're not going to face it again in the future, right? You're gaining that experience. Like now I know to check for overloaded functions when I'm calling something from a shared library. So it's really that experience that you gain that's incredible, but all sorts of scenarios.
That's great, Tanmay. And going on to the Divya's question, I would also like to ask you, what surprises you the most about your job?
Okay. What surprises me the most about my job? That's an interesting question. I guess I would say it depends on what you mean by my job, because I don't really have one job. As a matter of fact, I don't really like to think of it as a job in the first place. It's really just what I like to do. But if you were to take a look at like the aspect of where I take technology and make it simple for people to understand, or if you were to take a look at the aspect of programming and how I develop like cutting edge technology, I would say that on that end of how I develop like and research technology, the thing that surprises me a lot is that I'm able to touch so many lives, impact so many lives with the power of technology, right? Like, think about it. Implementing just an application can touch millions of lives if it's implemented the right way and if it's doing a good thing. It can impact millions of lives for the better. And that is, again, absolutely amazing. And then if you were to take a look at the other side of how I'm working towards enabling people to code, I would say it's pretty incredible how there seems to be a lack of real resources for people to get into programming in a way, or even just more generally, like forget even programming, just education in general. I find it surprising that there isn't a better structured education system in the world. Now, if you think about it, countries today, the vast majority of countries, the prosperity of those countries depend on the sort of intelligence of the population and the ability of the population of that country. So you would think that countries would be investing in better education systems to make it so that their population is able to adapt in the future because things are changing so rapidly. But not a lot of countries are doing that. In fact, barely any country is doing that. And even the ones that aren't necessarily doing it the best way. Education needs to happen in a more unstructured way. And I've found as I've gotten more and more into the world of education that I don't believe people are teaching in the optimal way. People should be teaching more in an example based and experience based way. and they should be specializing when it comes to fields. Like, for example, programming can't be taught the same way math or science or language is taught, because with programming you got to focus on generic logic, not on individual languages. So I would say what surprises me most about education is that we don't have better education systems. It's unintuitive. Like, if an alien not from Earth were to see how we teach people, they would say, why exactly are people being taught this way? So I mean, countries like Slovakia are doing a great job at sort of modernizing their education, and I hope that more and more countries are able to follow suit.
Yes, exactly. Present education system needs to get modernized.
Precisely.
Yeah. So where do you get these great ideas from in your organization?
In my organization, well, kind of depends on what you mean by ideas and organization again, because there's quite a bit of work that I do. Um, So, like, for example, the project that I was talking about, around injecting function tracing into the IBM code base, that idea came from some of the leadership of the product in IBM, and they were like, "Hey, we have this problem." And this problem is that we've got a really large code base, we've got lots of tests, and we don't know what test cases to run for pull requests. So what can we do? And so I was like, hey, instead of trying to analyze the test cases, what if we go to the code base and we say, all right, so can we dynamically at runtime try and figure out what all the function calls are throughout the program entirely automatically, and based off of that try and figure out what test cases to run. So in that case, I came up with the idea of how to implement it, but the general problem statement did come from different leadership in the product. Apart from that, if you take a look at ideas like, I mean, I've got quite a few different projects that I'm doing outside of IBM. Like, for example, and I'll give two examples. First of all, the projects that I'm working on in terms of writing books. So I've got a new series with McGraw-Hill Education called the Tanmay Teaches series of books. The latest in that series is called Tanmay Teaches Julia, which I've actually got with me right now. And the Julia book that I wrote, actually the entire reason that I wrote this, and I want to show you this, is because Julia is a language around machine learning technology. It's built around scientific computing. And the whole purpose of this book was, can you learn how to program with the goal of getting into machine learning? Because I found machine learning was important. I found not enough people know how to program at a young age. So can I build a book that first of all teaches you how to get into programming, but then at the end even gets you into examples of machine learning, like, for example, Google Deep Dream, right? So for example, being able to generate images with the power of machine learning technology. So that's one of the projects that I'm working on. Outside of that, there's also just generally all the ideas that I get from people, right? From people that reach out to me and that provide me with these ideas for different projects. Like, for example, a little while ago, I was working on a project called Project Cognitive, and this is something that I'm still continuing to evolve to this day. And the idea around that project is around providing artificial communication to people that can't communicate naturally. And the idea for that project came from the friend of a mom of a quadriplegic girl that reached out to the IBM Bluemix Twitter handle, which my mentor Timothy Duncan happened to be handling, who reached out to me and was like, hey, we should work on this project. So it's really this huge web of different connections. So each project comes about in its own way. Usually it's grounded in impact or research. So some of my projects exist pretty much purely for like the academic advancement of machine learning or technology in general. Some of them are more impact driven, where we've got this problem, we can't figure out what test cases to run, this girl can't communicate, whatever it is, we've got to solve that somehow. So there's all sorts of different ideas that I have, and they come from all different ways. But at the end of the day, they're used to impact people's lives for the better.
Well, that is a great talk with you, Mr. Tanmay. And just like us, many of the viewers watching this live stream are curious a lot about deep learning, about you, and they have been asking a few of the questions since the start of this event. And here are some of the questions which I would like to ask on behalf of you. And I would like to let you know that our viewers are from all over the world, from all over the age groups, and they were very enthusiastic about this event. So I'll start with a simple question. The first is how AI is different from ML or from DL, and can we predict what are the various applications of AI and ML in insurance and actuarial science?
Sure. So I'll answer those two questions separately. So let's start off with the difference between AI, machine learning, and deep learning. Let's start off, let's forget about machine learning, deep learning for a second. Actually, let's just forget about deep learning. Let's focus on AI versus machine learning first, and then we'll bring deep learning into the picture. So machine learning technology is what I've already described. It is pattern recognition at scale. You've got data sets X and Y, and you somehow got to find a mapping between them. You've got to find patterns that enable you to find that mapping. That's it. Now, the thing is, artificial intelligence is the same thing. The reason I say that is the only difference between machine learning and artificial intelligence is usually just a package that embodies that technology. So when we take machine learning technology, for example, on the Apple Watch, right? So you've got the Apple Watch, it does fall detection, that means it's machine learning. When you take machine learning and you put it on like a humanoid robot, for some reason people start to call it artificial intelligence. I don't really like that. I don't like the term artificial intelligence in general, which is why I don't use it very much. But the thing is, psychologically, because of our subconscious minds, and this is something that I've done a lot of research into, and that you might see more content from me on in the future, because of the way our minds are structured, we start to use different language just based off of that embodiment. Right? Just because we went from an Apple Watch to a humanoid robot, we went from calling it machine learning to artificial intelligence. Doesn't make that much technical sense because as a developer, I understand that it's basically the exact same math. But from a consumer and top level perspective, that's just how it is. So AI versus machine learning, not really much of a difference except for the fact that machine learning is more grounded and a technical term, and artificial intelligence is this sort of dream that people have of intelligent technology, where the intelligence is like human intelligence, even though that dream is not necessarily achievable. So that's what I would say. Now, machine learning, deep learning, that becomes a bit more tricky to sometimes quantify because deep learning technology is inspired by machine learning technology. Machine learning technology is the umbrella term with all sorts of algorithms, and deep learning is a subset of machine learning algorithms. So machine learning would be like linear and logistic regression, naive Bayes. You've got support vector machines, these sorts of things. And then under machine learning, you've got deep learning. And deep learning, you've got recurrent neural networks, convolutional neural networks, capsule neural networks, multi-layer perceptrons, and all these different kinds of algorithms. So I would say deep learning is under machine learning as this sort of umbrella term. They're all considered under the machine learning category. And then when you take machine learning and you sort of hype it up and you sort of see this dream of intelligent computing, then you start to call it artificial intelligence. And that's why I don't use the AI term very much, even though it's much more marketable, even though it's something that people recognize more and relate to more. I don't use that term much because it's not technically correct. So that's why I use machine learning a lot.
Well, we got to learn a lot about the word AI and why don't you refer it too much. Here's an interesting question from one of our viewers. And the gentleman's question is, can we predict the thoughts of individual on a real-time basis using the AI technology?
So I would say that the answer is so-so. And the reason I say that is not because of a limitation of AI, it's a limitation of us as humans. The brain is more complex than a lot of people can really imagine. The brain is incredibly complex. I mean, think about it. You've got billions, hundreds of billions, of hundreds of trillions, sorry, of synapses and hundreds of trillions of synapses, hundreds of billions of neurons. Now, what that means is there are so many connections between the neurons in your brain that it is impossible to map them out all on computers. And the thing is, the way neurons connect are very dynamic. As you run inference, you are somehow simultaneously running training because of the way the brain is structured. And we don't know how it's structured either. All we know is that, hey, there are neurons that are communicating via electrical and chemical interactions. And the thing is, sure, we can use things like electroencephalogram headsets to get a very rough idea of, hey, the frequency of your electrical activity is in the alpha band, therefore you're sleeping or you're relaxing. Or now it's in gamma or delta, so now you're healing a wound or something of that sort. But we cannot really get down to you are thinking of doing exactly this. Some research has been able to, with MRI scans, for example, trying to predict what word you're thinking about in your mind. So if I think and sit giraffe, the researchers will tell me, hey, you're thinking about a giraffe. Or, for example, taking electroencephalogram and recording people's dreams, at least on a very high level, super, super, super low res, and super, smudgy, but generally getting an idea of what's in someone's dream. Is it an animal? Is it maybe an elephant within that dream? You can do that sort of stuff. So at the very, very cutting, sort of bleeding edge of research, things like it are happening. But the reason it's not that evolved yet is not because of a limitation of machine learning technology. It's because of a limitation of understanding the electrical activity in the human brain, understanding the way neurons interact. That's the limitation. That's the bottleneck, not AI, not machine learning.
Well, it's great learning again. Tanmay, here's another question. As you mentioned, 80% of the data is unstructured, mostly being text. With a large corpus of unstructured text, what are some methods of gaining insight on this data? Can ML help the robots to take their own decisions or perform their own tasks?
Absolutely. That's the whole point of machine learning. Can you have technology, computers that make their own decisions instead of having to have human guided, or human coded decisions made for them? Now, the thing is that I would say it kind of depends on what you mean by decisions, though. And this is a bit of a side note. I'll get back to the original question. But sometimes you definitely want humans in the loop, regardless of machine learning. So, like, for example, if you've got a healthcare system that's trying to predict if it's trying to predict if someone has cancer or the treatment that they should have, then quite obviously you're going to need a human in the loop because you're not just going to offload that responsibility entirely to computers. However, what I will say is that it is most certainly possible it is most certainly possible to offload some decision-making tasks to computers. Now, what exactly do I mean by that? Well, let's take a look at some examples. So Project Debater that I had just shown you a little while ago, what it's doing is it's taking this very large corpus of unstructured data. In this case, it's taking the entirety of Wikipedia and 400 million news articles from LexisNexis. And what it's doing is it's understanding that unstructured data by using deep learning, and it's making decisions as to what arguments are relevant and which ones are not. That's not a life or death decision or situation, and therefore Project Debater can do it. And what it's doing in order to gain those insights is it's using techniques like BERT, which is a kind of neural network that understands unstructured text. And it's doing these sorts of analyses on the text. And so what I would say is how exactly you gain insight and whether or not you have a human in the loop very much depends on the it very much depends on the use case itself. And so one more thing I will end off with as another example of how I've been able to sort of garner insight with the power of machine learning would be there's an application that I built just a little while ago called Watson Feedback Insights. And Watson Feedback Insights uses the power of deep learning technology in order to take all this different feedback, literally hundreds or thousands of reviews that people might write about a certain product on Amazon or generally online on social media, or internal data, things like this, and take that data and try and extract insight from that feedback, determine quality of feedback. And the way it's doing this is by using BERT neural networks and special training techniques like Siamese and triplet training techniques in order to try and figure out the quality of feedback or the concepts mentioned or try and cluster them into similar groups. And so there's all sorts of stuff that you can do in order to garner insight from textual data. I would say it depends on your use case. It depends on what kind of insight it is that you want to get. But overall, deep learning technology is the perfect match for unstructured text. So if you give me some more detail, if you were to send another question with some more detail as to what kind of text you have or what kind of insight you want to garner, I would love to help out. If you're trying to do sentiment classification, you can train custom networks or you can use pre-trained ones like IBM Watson. If you're trying to do concept extraction, again, you can use services like Watson. If you're trying to do speech synthesis from the text, you can use things like Google WaveNet. So there's all sorts of things, and I would say it really depends on what exactly it is that you want to accomplish.
So well, we will tell our audience to be more specific, and if they want more knowledge about the particular subject, they'll send in more detailed knowledge. So I'll move on to the next question for now. Deep learning has bypassed feature engineering step of learning. Deep learning has bypassed feature engineering step of learning. Does that mean domain experts become irrelevant?
Not at all. That is the furthest from the truth. So let me tell you just this much. I always have believed that for a successful machine learning application, regardless of deep learning or not, you absolutely must work with domain experts at a one-to-one level. The engineers, the people building the deep learning systems, the people architecting them, need to be working themselves personally with domain experts. Otherwise, you will not have a successful user experience. It's that simple. Now, previously, machine learning required domain experts to also understand machine learning technology. Because without that, you couldn't have the domain experts actually put together the features that are necessary in order to understand the data. What deep learning does is it doesn't strip away the role of the domain expert. It strips away the need for the domain expert to understand how deep learning works. That's what it does. So for example, if you take a look at Project Debater, in order to build that, they still had to work with many professional human debate champions. And what they did is they worked with them to figure out how they debate, the individual things that they do, certain tips, certain feedback on the Project Debater system. And based off of that human in the loop process, they could build a better and better and better system. Without working with humans, they would have a terrible system. And that would be basically the engineer's representation of what they think debating is. I mean, think about if DeepMind built AlphaGo without any Go experts on the team. They would build a Go system that would essentially just be the engineer's representation of what they think Go is. Now, it might not be a one-to-one analogy because AlphaGo is self-learning, and so technically the engineers aren't really that involved. But the basic premise still holds. They worked with a whole team of professional Go players in order to test, validate, and improve the system. So at the end of the day, you must work with domain experts. They're absolutely critical. Developers need to work with them, and it's the reason it's so important is because you need that meaningful user experience to be built with the help of that domain expert.
Mr. Tanmay, as we have heard that you have two projects in medical science, so here's another question regarding the same subject. Can we predict the mortality and morbidity of the insurance policyholders by collecting information at the underwriting stage about the health status at the time taking out the insurance policy?
So I will say from a purely technological perspective, yes. Can you do it? Yes. Should you do it? Maybe. Now, in my opinion, should you do it as a yes, because it's useful, right? It doesn't hurt having that data on you. But a lot of people would argue no. And I also understand why people would argue no, because that opens up the opportunity for bias. That opens up the opportunity for a lot of different things and certain questionable decisions in terms of ethics that maybe you don't want to open up that can of worms right now, is what the insurance company would think. But I would say that a truly innovative insurance company would build that solution. Now, the reason that's possible is because if you think about it, assuming you don't have outside variables, the mortality is directly linked to the features that are being gathered by the insurance company. And that is definitely something that they can calculate because we know there's a causal link. The features that they gather can somehow be transformed into mortality. The question is, Will they have the data? Will they have the legal rights to use that data? And will their customers be okay with them using that data? So if they're able to create a solution that is acceptable to people and they're able to prove that they're not biasing their decisions based off of it, then I would say it's a definite yes.
All right. Another similar kind of questions we have, and this is related to the COVID-19,
Mhm.
and it asks us how can we use AI technology in understanding the epidemiology model of the SIR for the current coronavirus situation worldwide and try to curb the infection.
All right. So here's the thing. Machine learning technology, it's incredibly useful, but applying machine learning to coronavirus is pretty new. All right. So data sets have just started popping up in the wild. We've just started to get like actual clear pictures of what's happening around the world. Um, Things are very, very new and very rapidly changing. So I would say that right now is a little bit too early to comment on definitively what kind of impact machine learning will have on pandemic response. I will say, though, that machine learning has already played a role. For example, the Canadian government has a machine learning based system that looks at flight patterns and based off of it predicts when a pandemic is about to start. And they were the ones that predicted this pandemic before the Chinese government shared it with anybody else a very, very long time ago, before any other government knew about it. And they were using, obviously, machine learning technology to do this. So what I would say is we would have to wait a little bit more for new patterns, new technologies, new applications to emerge. But there are already lots of people doing really interesting things. Machine learning companies that specialize in natural language understanding have already built demos. I'm forgetting exactly what the name of the company was, but they've built a demo around creating a knowledge graph of all the different COVID-19 research papers and being able to answer questions, natural language questions based off of that. So people are using machine learning to help with pandemic response, but right now the main priority is understanding it at a human level, putting the resources to do that in order to make sure we're making the right decisions. And then from there, there are also people invested in using machine learning in order to accelerate the decisions that we make. So far, there haven't been that many applications of machine learning in this area, at least majorly useful ones. But once there are, I'm sure we're going to hear about it.
Okay.
Oh, one more thing. Sorry to interrupt. Just one more thing that I will mention. There is actually one thing I would like to show you, which I can probably do here. If we go into this web page, let me just make sure it's still available. Yes, it is. So if I launch this, this is an IBM research project that enables you to explore novel drug candidates for COVID-19. So they've built a machine learning system, which this isn't necessarily related to the epidemiology that you mentioned a little while ago, but this is related to generating or creating a drug for COVID-19. So they took 3,000 new molecules and they use machine learning to filter out the ones they know won't be effective so they can only focus on the ones that actually do have scope of working. So this is the kind of technology that enables doctors to accelerate discovery. So as you can tell with this demo, you can take a look at different molecules and the different factors that AI predicts for them without actually having to test it yourself. So there are different applications. It's just we're still working on, how impactful will these applications be. Oh, I think you're muted. At least I can't hear you. I can't seem to hear
I
you.
guess I
There we
guess you are muted, Harsh. Yeah, Harsh, can you repeat the question?
Still can't hear you. Are you calling in from your phone maybe? Like, are you muted on your phone, or are your headphones disconnected if you're wearing headphones?
Okay, Tanmay, am I audible to you?
Yes, I can hear you.
Yeah, so we have one question from one of the viewer. So is it useless for him to learn Python for machine learning? Because there are many resources on internet that says that Python is not the language of future and that new languages are going to beat Python. What are your views on this?
First of all, I absolutely agree that Python is most certainly not the language of the future. Eventually, people are definitely going to be migrating away from Python, and the reason for that is actually pretty simple. It's because Python wasn't built for what it's doing right now. It's like you tried to take it's like you tried to take a foundation that was never meant for a mansion and you tried to build a mansion on top of it. It's not working, and developers have been frustrated at working with Python for many years now, and they're not going to be taking this frustration for much longer. There are already new projects like the Julia language and the Swift for TensorFlow project that believe that machine learning is so important that it deserves first-class support within the programming language compiler, and I completely agree with them. Swift for TensorFlow in specific is my favorite deep learning framework so far. And the reason is just because Swift is an absolutely excellent open source language that enables you to program all sorts of applications, and at the same time, because of the way its compiler, because the way its compiler is structured, enables you to do things like automatic differentiation and all sorts of stuff within the language. So I would recommend that for now, learn Python. Because it's simple, it's not going to take you a long time to learn, and you'll be able to start working now. But make sure that you realize that things are going to change in the future. You need to learn more languages. I would recommend Swift and Julia because those are the two sort of at the forefront. And just be ready to switch. Be ready to understand that, hey, I know these concepts and I can implement them in any language regardless of what framework I'm using because I understand the logic. Because once you know that logic, you can implement it anywhere. So learn Python for now because that's how you're going to get a job. But then eventually things are going to change because developers won't take the frustration for much longer. Oops, Harsh, I still
So
can't.
yeah, so there is a question from a newbie that how can he start his career in machine learning?
Sorry, I didn't get that middle word.
How can he start his career in machine learning?
His career. Okay. So, well, see, this is a pretty open-ended question because machine learning, there are all kinds of machine learning places to start off with. Now, you could start off with, well, so actually, let's break this up into pieces. Machine learning isn't just one thing. You can either focus on the data science and machine learning aspect of the machine learning industry, and that's how you can start your career. Or you can focus on the compiler and the implementation of machine learning technology, or you can focus on the frameworks and how machine learning technologies actually run. You can focus on the GPU kernels and the hardware acceleration. There's all these things you can do. Let's just say, though, that for the sake of assumption, you want to start off with the data science and machine learning aspect. I would recommend that first of all realize that don't start your career saying, I want to do machine learning and then start. Say, I want to solve problems. I'm going to be a programmer, and programmers solve problems, right? And as a programmer, I also want to specialize in data science and machine learning so that I can solve more complex problems than other programmers can. So jump into it with a programming first mindset, a problem solving first mindset, a computer science first mindset, and then from there delve deeper into languages like Python, frameworks like TensorFlow, frameworks like PyTorch, or other languages like Swift for TensorFlow and Julia, and over time gain more and more experience with these different frameworks, build example applications, take a look at things like online Kaggle challenges, and really give yourself these problems that you think you should solve. And over time, you're going to be building up enough experience that's going to enable you to get into this world of machine learning and sort of data science as a career. So that's how I would recommend getting started. If you mean in terms of like actually like getting jobs and things like that, unfortunately, I don't have experience getting a job myself just yet. But so I can't necessarily comment too much on the actual like more career aspects of that. But what I can say is this is the best way to get into machine learning, data science, is focus on the problem solving nature and focus on the example based learning is what I would say.
Yeah, so Tanmay, so do you think reinforcement learning and deep learning will complement each other?
So So here's the thing, reinforcement learning is a kind of technique for training machine learning systems. Now, what the machine learning system is that you train could be deep learning, or it could be regular machine learning, it could be anything really. But as long as it's compatible, I mean, take that with a bit of a grain of salt. But any kind of machine learning algorithm, including deep learning algorithms, are technically compatible with reinforcement learning techniques. Now, there are different kinds of reinforcement learning techniques, and in my opinion, deep learning and reinforcement learning definitely go hand in hand. For example, AlphaGo, deep reinforcement learning. It's self-play. It's playing completely on its own, and based off of that, it's learning to play Go better than the best human champions. It is learning from absolutely zero human games, Alpha Zero. So Alpha Zero, the system called Alpha Zero, is learning from no human games, only playing against previous versions of itself, and it's gaining superhuman, super bot performance. It's learning to play better than the versions of AlphaGo that were trained with human data. And so I would say that reinforcement and deep learning do definitely go hand in hand. It's just that I would say that it's maybe not necessarily as useful in business. And the reason I say that is because within games, we have a very, very clear score. In Go, you know how much territory you have. In the game of in any other chess, you know based off of heuristics where you are in the game. You know you've won when the other side's king is gone. So you know when you've won or when you've lost. But the thing is, in the real world, you don't really have that clear of a picture of the world. You don't know if you've won or lost if you've diagnosed someone with a certain type of cancer and you've given them a certain kind of treatment. It could have been that a different treatment would have also been successful. It's more difficult to apply reinforcement learning in the real world. But I will say that it's useful. They go hand in hand. Where it can be applied, that remains to be seen.
Okay. So over to you, Harsh Bansal. I guess he's still not audible. So let me continue with the same. Tanmay, what are your views regarding the quantum computing? Will it revolutionize the deep learning?
Ooh, okay. Um, Unfortunately, I don't like saying this, but very unfortunately, my answer is going to have to be it depends. And let me expand upon that a bit more. So quantum computing, first of all, I love the technology. Quantum computing makes a lot of sense. It's the kind of technology that really excites me. I've been getting into it myself quite a bit. It's super interesting, super fascinating. But the thing is, quantum computers are so incredibly early stage right now. There is a very long way to go. Right now, our qubits can't even hold a superposition for less than a micro. Can you hear me?
Hello.
Yes, there we go.
Yeah,
So
I can hear you.
for
I
some reason,
guess some technical snags.
yep,
I'm sorry
apparently
about
my
it.
WebEx crashed. But as I was mentioning, there is a very long way to go in the world of quantum computation. Our qubits can hold
Mhm.
superposition for less than a microsecond. We're definitely going to need to increase that. And we're also going to need to decrease the error rates of our current qubits by orders of magnitude if we want them to do anything useful. But
Audience, we will wait for a while, like while Tanmay rejoins our event. Thank you.
Is this better?
Yeah, Tanmay, you're
Oh,
audible.
okay, so I think there's somehow two versions of me on the meeting. So you're gonna
Mhm.
have to kick off the other one, not the one that I'm actually currently on.
Okay.
Uh, but as you do that, I'm going to continue my answer. So as I was saying, quantum computation still a long way to go, still many things to do. But I think you muted the version of me that is actually online right now. There we go. Now it's better. So yes, as I was saying, this quantum computation, as we start to develop better quantum computers, we're gonna start to get a picture of how quantum computers are gonna change the way we compute. Because they're not gonna replace regular computers under any circumstances. They're gonna work alongside regular computers for very, very specific tasks. I mean, adding 1 plus 1 on a regular computer takes orders of magnitude less power than a quantum computer because every quantum operation needs to be reversible. That's just how quantum physics works. And so, what I would say is most tasks will still be done on regular computers. Maybe some certain problems under the deep learning umbrella will be solved by quantum ASICs, but then they're going to be moved right back to classical computers in order to continue to solve that problem. So I would say that we still have to see what algorithms people invent for quantum computers, how we end up working with the technology. But overall, I would say that there's definitely going to be some kind of impact quantum computing has on deep learning. We just can't be sure how big it is right now.
So yeah, what can you say about the future of ML and deep learning itself also? So how much we can achieve in this decade?
So, I mean, I can barely predict the next few months, and the reason I say that is not because it's not because it's really because deep learning technology, machine learning technology evolves very quickly, more quickly than you can imagine, actually. I mean, if you think about it, let's just take a look at generative adversarial networks, GANs. These special neural networks that everybody's talking about like generating data, they didn't exist up until, around a few years ago. And back then, before GANs existed, we never could have predicted that neural networks would ever be as good as they are today at generating data. But literally, that one sample architecture that Ian Goodfellow put together one night happened to completely change the way we generate data with neural networks. So, in one night, literally everything changed when it comes to neural networks generating stuff. And so I would say because of things like that, it's difficult to really predict. But if I had to predict, I will say that a major revolution in machine learning technology is about to come. And that major revolution is not technical in any way, it is psychological. People will start to understand that machine learning technology isn't nearly as, I wouldn't say powerful, but as as intense as they thought it was, right? Currently, people think, hey, machine learning, that must be real intelligence on a computer, right? They see these like these very futuristic, hey, we're gonna have like humans on our laptops and on our phones now, but that's not the case at all. That couldn't be further from the truth, in fact. And as more and more people start to set their expectations really high just to see them come right back down, we're going to start to realize, oh, wait, maybe machine learning can't do what we thought it could. And people will start to say, it can't do what we thought it could, but it's still immensely useful. It's still saving millions of lives by helping us diagnose diseases and help us determine treatments and find drugs for diseases and all these sorts of things. So the next major revolution in machine learning, I believe, isn't even technical. It's more psychological and societal.
So yeah, Tanmay, one interesting question from my side. Like when I was like age 16, I used to play FIFA and Cricket 7 or the GTA Vice City. So like during your age, like you started learning since you were 7. So do you think so? Like what are your views that should students in each and every country be included like all these courses and all these like methods and all this should be that should be included in their course curriculums? What are your views on this?
So I strongly believe that everybody has their own areas of interest. right? So mine happened to be technology because at a very young age, I decided, hey, the computer lets me do more things than my other toy, so therefore I'm going to use the computer, right? So it was a very, very primitive decision at that point. It was just, I'm having more fun with the computer, and so I have been on the computer ever since. But everybody else has different interests, right? It could be art, it could be science, it could be language. I know language and linguistics and psychology really interest me. There it could be, history, it could be really, really anything. So I believe that when it comes to things like programming, at least, everything should be introduced to kids so that you can help them figure out what it is that they're passionate about. Because if they don't have experience with something, they're never going to figure that out. If I didn't have a computer when I was 5, I wouldn't know I was passionate about computing until much, much later, at which point it would have been, I wouldn't say the word too late, but for lack of a better phrase, it would have been too late in the sense that I wouldn't have started that early. But what I will say is you don't want to push everyone very far down the rabbit hole in every single field. Because if you do that, you're going to overburden and overstress everybody. Because nobody wants to learn everything about everything. And because that's infeasible, especially for kids. I mean, especially for the youth. And so I would say that introductions and sort of intermediate, definitely, because people need to get introduced to everything. And I mean, when you learn like something in one field, you're not even just learning about that field. You are just generically learning the framework of human problem solving. So it is very important to introduce them to it, but then not necessarily as important to drive them deep down. This is the intuition behind why calculus works, right? You don't necessarily need to understand that just to understand deep learning, but definitely do understand that, hey, gradient descent is the optimization algorithm used to train a neural network, right? That much definitely. So I would say it's very important because kids are gonna in the future work in industries that we don't even have yet, that don't exist right now. So if they're gonna be ready for that, they've got to be able to adapt. They've got to build a generic problem-solving framework in their mind based off of the hundreds and thousands of problems that we've solved in the past. So yes, it's very important. Maybe we don't want to go all the way though.
So I hope kids in India are listening to this. So what are the risks in implementing incorrect algorithms, and how do we ensure that algorithms are indeed working in all the circumstances?
Right. So, see, the thing is, you said the word algorithms there in the question, and the word algorithms is weird because that's very open-ended. There is a way to mathematically ensure that a sorting algorithm will always return the correct results. Like you can mathematically define this sorting algorithm will never, it will be physically impossible for the sorting algorithm to return an incorrect answer. You can do that totally. But then when it comes to machine learning or deep learning, those kinds of algorithms, that becomes a lot more difficult. In fact, I would say impossible. No machine learning algorithm will always return the correct results for a certain piece of data because unstructured data is fundamentally subjective. A certain sentence might mean something to you and something else to me, and the machine learning algorithms were going to have to choose a certain interpretation that they want to provide to you. A certain image might look like it contains a dog to you or might look like it contains a cat to me, and the machine learning algorithm needs to give you an interpretation. An image might look like it just contains an ostrich, but based off of some sort of mathematical noise you throw into it, the machine learning model might say it's a school bus, right? And so at the end of the day, unstructured data is subjective. It is not defined. It is not structured data. That's why it's so difficult to understand. So no machine learning algorithm or deep learning algorithm can ever be 100% verified down to mathematical, universal ground truth. But we can get it down to enough to work in the use case. So for example, if we're talking about, let's just say, a certain machine learning application that is an AI in a game and it plays against you, that's definitely not a life or death scenario. So even if it's at 95% accuracy and 5% of the time the user wins, it doesn't really matter, does it? But then when you've got a neural network that is driving, you're going to want to validate that against as much data as you've got. In this case, Tesla is using millions of miles and millions of hours of driving data that they've gathered from real cars in the real world. This is noisy data and it's representative of what you're going to see in the wild. But then if you are doing something even more important and life-threatening, like, for example, diagnosing and trying to treat cancer, again, we're getting back to that same example, then you definitely need a human in the loop, because even if your machine learning model is at 99.99% accuracy, there's always edge cases that the network has never seen before. So I would say there's no way to concretely verify universally, yes, it works. But you can definitely say that, hey, it's close enough to perfect for this use case, right? So that's what I would say. It's use case dependent.
So your inspirational guru, like Elon Musk, Jack Ma, also they said like AI is killing jobs. So what are your views? Because in one of your session, like somewhat 2 or 3 years ago, you also said the same. So what are your views to this generation, like for the bachelor's and master's student who are pursuing their research and their studies in the field of AI?
So, so first of all, I may have said that artificial intelligence is going to replace jobs, but if you take a look at what I said after that in context, I would have definitely said that artificial intelligence, sure, it's going to replace jobs, but it's going to create many more than it's ever going to replace. And it's going to create higher value jobs than the jobs it's going to replace. And the reason I want you to think about it this way. Right now, we're in the midst of a pandemic, unfortunately. And during this pandemic, there are essential workers that are, for example, at grocery stores, or they work in healthcare, or all these different fields where they kind of have to work. Delivery drivers, truck drivers, they kind of have to work, because if they don't, the entire fabric and infrastructure of society will break down and nothing will ever get done. So they have to work, right? That's a given. They're gonna have to work. But the problem is they don't really need to, because think about it, humans, we've evolved for tens of millions of years in the wild. We never drove in the wild. We're one of the only animals with blind spots in our eyes. And we drive. We were not meant to drive. In fact, Oxford did a bit of a study as to if, for the next few millions of years, if natural selection only chose the people that are most likely to survive in a car crash, what would we look like? And it looks like this mutant human that you can't even recognize. And that's just because we weren't meant to drive. We weren't meant to work at grocery stores, as cashiers. We weren't meant to, transport things from one area to another in a hospital. That's not what we do. The entire thing that makes us unique from animals is that we can reason. We have this multi-hop reasoning capability in our minds. And many jobs require this, like, for example, jobs in art or entertainment or history or technology or science or math. These jobs require that mental reasoning power. But jobs like, for example, as I mentioned, at a grocery store, as a truck driver, they don't really require that mental reasoning. It's just that redundant, repetitive work. Imagine right now in this pandemic, if we were using AI in all of those scenarios and not a single human was out on the roads doing unnecessary work. This pandemic would have lasted a lot less than what it is currently, because they are definitely vectors of spreading the disease. Um, so what I would say is artificial intelligence, sure, absolutely, it's going to replace jobs. It's going to replace lots of jobs. But it's going to create whole industries that we don't even know will exist right now. It's going to create technologies that we can't even envision could exist currently. So what I would say is we've always been afraid of change, right? We as humans instinctively, innately, we want to live. We have self-preservation instincts, so we're afraid of change, especially when it's on such a large scale like AI, machine learning. But overall, remember that first of all, it's not generally intelligent, so we're not going to be seeing like superhuman intelligence in computers ever, at least with the current technology, current software that we have. And second, it's going to replace jobs, but it's going to create more and higher value jobs than ever possible before, enabling almost every member of the human population to directly contribute to etching away at the sort of boundary of human knowledge, enabling us to innovate at a scale never before possible.
So Tanmay, there are plenty of questions tonight. But one last question before we move to the quick fire round and then the closing note. So one last question is like, means are these fields like AI, ML, and like deep learning helpful for the game development? Like because there are a lot of gamers in this
Yes,
world. So
absolutely.
what are your views on this? Yeah.
Certainly. So, machine learning is incredible for game development. Now, I'm forgetting what the game is, so forgive me if I get this wrong. But I believe the game was some kind of Super Mario Brothers game. And in the game, you're allowed to build like your own custom levels and maps and share them with other players. And a person on YouTube actually built a custom machine learning algorithm to automatically generate fun maps to play on. So you don't need to work off of maps that other people have generated. You don't need to work off of maps from the game. You can actually have neural networks automatically generate these maps for you, and just like that, you've got infinite worlds to play on. So yeah, neural networks are totally useful for game development. They're also very useful for playing games. So like for example, there are lots of like strategy games where it's very, very, very difficult to create competent AI players because at that point you're hard coding rules, and strategy is pretty much the opposite of that. Strategy is real reasoning. So human players end up dominating the game, and the AI players end up just kind of sitting in the corner waiting for the humans to capture them. So with real machine learning technology, like for example applying say similar techniques to what AlphaGo and the StarCraft playing AI do, we can start to actually have machine learning systems that are competent and actually give you a challenge just like a real human player. In some cases, far exceeding human performance and totally dominating the human players at that point. So yeah, machine learning is really useful. But I want to take a step back. You said, is it useful for game development in specific? Game development, let's generalize that even further. Can we use machine learning for coding? Can we? Yes. Right? So like I was talking about that project about predicting what test cases to run for a large code base, that uses machine learning. But then you've also got to take a look at another aspect of this, which is a lot of people think that, hey, what if machine learning were to do the developer's job for you? And there's a very famous comic that I like to point to, a comic strip, whenever anyone mentions that. And the comic goes something like this. I forgot where it's from, where someone goes up to a programmer and says, "Hey, you know what? We won't need to hire programmers in the future." And the programmer says, "You know what? You're right. We can just create a spec that's incredibly detailed and precise, and we won't need people to code anymore." And he's like, "Yeah, you're right." And the programmer says, "Do you know what that spec is called? It's called code." and so, and so the thing is, we're always going to need developers to write code. Because when you say even something as simple as grab names from a database, there is so much more than just select names from database or from table. It's what kind of text encoding do you want? What kind of data format do you want to use? What kind of compression do you want to have from the database? What kind of limit do you want to have in the number of data rows that you're getting? What kind of filters do you want to have? There's so much there that you need human reasoning in order to decide how exactly to achieve a certain task. Because even something that seems very specific, like go grab something from this table for me, is actually very open-ended. And so, because coding is more logic and creativity and reasoning and less code writing, we're not going to see machine learning replace the role of developers, but instead, we're going to see machine learning help developers to write code faster.
Yeah, so we now move on to quick fire round. So
Right.
first question is like, which is more important to you, model accuracy or model performance?
Ooh, I would say model accuracy, but that's only because of the compute power that I can run them on, and at the same time, not just that, the use cases that I'm using them for. For mobile use cases, performance, but every other use case, in my opinion, accuracy.
So let's say you have extremely small memory or storage. What kind of algorithm would you prefer? Logistic regression or nearest neighbor?
Ooh, what is regression nearest neighbor? I would say nearest neighbor to use less
I guess
memory.
this is interesting for you.
This is interesting. I'm not exactly sure which one would use less memory. I would say it would depend on the implementation, and it would also depend on the data set. If you've got very few data points but lots and lots of features, then nearest neighbors would probably be faster. But then if you've got lots of data points but only a few features, logistic regression would probably use less memory. So it depends on your data set, is what I would say. And it depends on your implementation too.
So Tanmay, what is the procedure to work with you or to work under you at IBM?
Nobody works under me at IBM, all right? People work with me. I would say it's mostly just if you're on the team that I'm on. So I'm working on a couple of different projects at IBM, right? So one of them is around creating courses for something called cognitive class. One of them is building this compiler tooling I was talking about. I'm working on natural language question answering stuff. I'm working on a new project around natural language processing, all sorts of stuff. And it really depends. I mean, if you happen to be on the team that was sort of assigned to the project and something that I'm working on, then I guess we're going to be working together. But I mean, in general, if you have any ideas, I mean, even outside of IBM, right, just externally, feel free to reach out to me, and I would love to sort of see if it's an idea that we can collaborate on. Feel free to email me or reach out to me on social media like LinkedIn, and we can definitely get in touch.
So you will be receiving plenty of messages tonight.
I can't wait.
So yeah, again, like so we are living this technical stuff. Now on the non-technical stuff, like your favorite hobby.
Ooh, my favorite hobby. Well, I like to code, but apart from code, there's also things like table tennis and biking. Obviously, can't do as much biking due
Oh.
to coronavirus stuff, but table tennis, we do have a table tennis table indoors, so table tennis is really nice.
So Netflix or reading books?
I would say it depends on the book. I usually watch a lot of Netflix though, whenever I'm not coding at least. Yeah, it depends.
So sci-fi thriller or realist drama documentary?
Realist, absolutely realist. I kind of, because I work with technology myself, when I see like sci-fi stuff and I see what people think of technology or what could happen in the future, it kind of, for lack of a better word, it kind of frustrates me in a way. Looking at like how people view what technology might be like in the future, knowing that that kind of technology isn't just far off, it's near impossible, like how people represent AI, like in movies and stuff. So realist for sure.
So which is your favorite movie?
Ooh, my favorite movie? It would have to be a tie between the second SpongeBob movie, not the third, the second, and Home Alone, Home Alone 3 in specific.
Whoa. So one interesting question. I guess your family would be laughing on that. India or Canada?
It's hard to say because I live in Canada. My grandparents and my cousin live in India. It's really hard to say. I'm gonna have to say I like both. I prefer India's weather by far. I do not like the snow. But then at the same time, I love Indian food, right? So like for
Oh,
example, butter chicken, I love Indian food. The people in India are amazing and generally I like India a lot. So I would say it's both are good in their own ways. Like mangoes, for example, you simply do not get the kinds of mangoes that you get in India in Canada, right? So there are lots of things that India has that I absolutely just love. So it's hard to say.
so job or entrepreneurship?
So here's the thing. It depends on what you mean by entrepreneurship or job. Because the thing is, on one hand, I absolutely love like being able to work at the cutting edge of innovation and building technology. But at the same time, I don't have nearly as much interest in the world of business or actually running a company and finance and things like that, right? My interest is in pure technological innovation and really pushing forward the boundaries of technology. It's not in the running of a company that handles technology, right? So I would absolutely love entrepreneurship as long as I got to handle all the technology and the innovation and that sort of academic portion.
Restaurants or home cooked food?
It depends on who's cooking the food at home, uh, is what I would say. There are lots of things that I like from both home and restaurant cooked food. I mean, my favorite fast food is Wendy's by far. Unfortunately, me nor my parents know how to cook, the best butter chicken. So sometimes, actually, no, my mom does cook something similar to butter chicken that's pretty nice. It's gonna have to be a tie, and it depends on exactly what food item we're talking about.
You can only choose one.
Oh, if I had to do one for the rest of my life, if I had to choose, just for because I have good enough options and because of the fact that I would probably live longer, home cooked food.
So things you like about yourself.
That would be hard to say. Let's see. What do I like about myself? Um, Honestly, I feel like that's a question that other people could probably answer better than me. Uh, like as to what they like about me. I guess something that I enjoy is sort of my curiosity and the fact that I'm just, a lot of people would think like for example when I go to a conference, right? Whenever I go to an event, they're like and I'm having like for example dinner with the conference organizers or whatever. They're like, when we saw you in YouTube videos, we thought you would be completely different, and now when we're seeing you in person, you're like so much simpler than we thought you would be. A lot of people think I'm very different from what I actually end up being in real life. I'm pretty simple. I mean, it's there's not much complexity to life. It's just I do what I'm interested in and what I find enjoyable. So I'd say that's it.
So lining up things you hate about yourself,
Hate about myself.
or
Uh,
either your family, your mom, your dad would hate about yourself. One thing,
what would they hate about me? Maybe the
because
fact
you
that I
look like a complete person.
well, that's the thing. I look completely different than what I am. But well, maybe it would be the fact that I get like so incredibly like focused on technology and code that I will literally go hours and hours without like eating or drinking anything and just like consistently coding and consistently working on like an application until it's fixed. Like when I was encountering that bug, the operator, the memory allocation, sorry, the recursive bug in that large code base, I simply could not think about anything else until that was finished. A few days ago, I encountered an error with automatic differentiation, and I was like, "Why am I not getting the gradients for a recurrent weight in my recurrent cell?" And turned out because I wasn't calculating the error over more than a single time step. And so I would say it's the fact that I get like really sometimes very narrowly focused on like fixing something or working with something related to technology, and I will forget literally everything else until I'm able to solve that and until I can finally sleep again after fixing it.
So once you turn 40, will you be going for a world tour and adventure or continue coding?
Who says you can't do both? I mean, so honestly, both would make sense to me, but it also kind of depends on what you mean by world tour. Do you mean just generally as like to see the world, or continuing to speak at different conferences and stuff like that? So
So
like,
scuba diving or skydiving or both?
see, the thing is, I'm interested in skydiving, but it seems like an interesting concept to me, but I generally do not like heights at all. uh, so skydiving doesn't particularly, I mean, so I would say it would be a tie between scuba diving and indoor skydiving.
So Sunday or weekdays?
Uh, well, see, the thing is, because nobody else is online on Slack on the weekend, you get to do a lot of work by yourself. So the weekends are more convenient because you can work all day without anybody interrupting you. But then weekdays are sometimes more efficient because then you can actually work with people without them not being at work. So, unfortunately, people aren't available when I ping them on Slack on the weekend. Sometimes weekdays, depending on what I'm working on, sometimes weekends. I keep flicking back and forth.
So describe yourself as a teenager in 3 words.
The teenager word there is going to kind of throw me off because I mean, I could probably describe myself as a person in 3 words, but I don't know how I would best describe myself as a teenager in 3 words. There's someone, well, I'm not particularly sure. Probably um, fun, curious, and so fun, curious, and let's see. I mean, I can think of those 2 words, fun and curious. I can't get another adjective though, right? I can think of a few nouns and stuff, but I can't get another adjective to describe myself. Fun, curious, and I would say,
Intelligent, of course you are.
well, that's for you to judge.
So your nicknames.
Ooh, nicknames. Let's see. What are my nicknames actually? I not really ringing a bell immediately. Let's see. Oh yes, my mom calls me Ishu, which is I forgot the meaning of it. But there is a special meaning to it, that I don't recall right now. But yeah,
So favorite football club, if you are following football.
not following football, unfortunately.
Okay. Yes, best gift you have received till now.
Best gift I've ever received till now. Huh. Well, there's lots of gifts that I've gotten, specifically a lot of gifts from my mentors, that I've gotten. I would say the best gift that I've gotten so far, the one that would be like most rare, would be from a guy named Steve. So this is actually a pretty incredible gift. It's the gift of compute power, that I got from the CEO of Nimbix, Steve Hebert. I work with Nimbix on a bunch of different machine learning powered applications and high performance compute powered applications. And even generally being able to have the infrastructure to work on the applications that I work on is truly incredible. So I would say that is the best gift I've ever received. But the thing is, at the same time, there are many different gifts, so I can't really choose. But if I had to, I would say that's the one.
So if you had one superpower, what would it be? Like Captain America, Tony Stark.
If I had one superpower, what would it be? Let's see. I would love to be able to find, uh, you know what? Considering the current situation, my superpower would be to solve, or my superpower would be able to take any microbe and create a vaccine that works, that is able to train your immune system to fight against that microbe, which would be very, very useful considering the current situation. That would actually be a pretty incredible superpower to have.
So any plans in future to come to India, especially at IEEE ADIT Student Branch, Gujarat, India?
I would absolutely love to. Currently, I'm not sure when I'm coming to India next. Maybe towards the end of the year if things start to get better by then, but or else right after this. And if I do, I would absolutely love to visit the student branch, IEEE ADIT. Whenever I'm there next, I would love that.
So one last question, like, can you share your message to this beautiful audience?
Certainly. Well, so to be really, what I would say is there are a few different things that I usually say, or a few different messages that I want to get across. And I would say it depends on where you are currently, which area you're in, or what your goals are. Right now, I would say generically for everybody is simple: follow your heart, follow your passion, do what it is that you love to do. Right. So doesn't matter if it's programming or deep learning. You don't need to do deep learning just because it's the next gen tech. You don't need to do technology just because, hey, it's the field it'll get a job in. Do whatever it is that you are genuinely passionate about. Do whatever it is that makes you happy, in my opinion. And the reason I say that is because only then will you genuinely be persistent and excel in that field. Right? If you're doing technology just for the sake of getting a job in tech, you're not going to be a great programmer. You should be doing technology because you are genuinely passionate about it, right? Like working on the weekends and doing things like this just because it's fun for you. It's what you do as your hobby, code. So I would say that it's do whatever it is that you're passionate about, follow your heart, stay persistent, stay perseverant, and just remember that whenever you encounter a roadblock, that's just what it is. It's a roadblock. It's not a brick wall, it's a roadblock. You're going to get over it eventually, and you're going to gain experience from every one that you encounter.
And like your life motto or like one life lesson which you will be following right now?
Hard to say. If I had to say a single life lesson, maybe it would be stay positive, right? And this kind of ties back into what I was saying with staying perseverant. And that is, no matter what the situation is, we as humans have always found a way out of it, right? We've found ways out of much worse situations than the one we're in right now. We found ways to fix bugs and issues and create things that we never thought we would ever create. So at the end of the day, human ingenuity is a lot more powerful than you may think. And so stay positive and really just, again, whenever you think there's a roadblock, just remember that we're all gaining experience, we're all learning from it, and hopefully in the future we won't be making similar mistakes again.
So hats off, Tanmay.
Thank you very much. Thank you.
Yeah, so like I'll be handing over to Divya and Dhruvin, who will be giving a closing note. But do consider clicking a selfie.
Definitely.
You can post that on your social media handles. It would be interesting.
Certainly. I will do that. I will post that on my social media, and I definitely encourage everybody on the live stream as well. Take your own selfies as you watch the live stream, post that on social media, put in the hashtags, and I can't wait to see them.
Thank you so much, Tanmay. Over to you, Divya and Dhruvin.
Thank you.
It was indeed a great session, Tanmay Bakshi. On the behalf of IEEE ADIT Student Branch, I expresses a deep sense of gratitude towards Mr. Tanmay Bakshi sir for allotting his precious time for his busy schedule, for being the speaker for our webinar, Deep Learning and Folding the Concepts. Thank you so much, sir. Uh, we also thank you to all the participants for turning out in a huge number for the success of this webinar. Moreover, our student branch is immensely grateful towards all the volunteers and the entire team for extending endless efforts for the fruitfulness of this webinar. Thank you so much, everyone. Thank you so much. So stay home, stay safe, and good night.
Thank you. Bye-bye.
Bye.
Bye, Tanmay.
Bye-bye.
Have a great day.
You too. Bye.